Okay, solving linear inequalities. Here you see two examples of linear inequalities. X plus 2 is greater than 0. 8x plus 1 is greater than or equal to 5x minus 2. As you can see, linear inequalities are very similar to linear equations. The only difference is that instead of an equality sign, you have one of these four signs: greater than or equal to, less than or equal to. When you're solving a linear equation like x plus 2 equals 0, then the solution is x equals negative 2. It's only 1 point. But in the case of a linear inequality, the solution is always a set. So for example, if x plus 2 is greater than 0, then this implies that x is greater than negative 2. So all those numbers that are greater than negative 2 are considered to be a solution of this linear inequality. For example, 3 is a solution, 4 is a solution, 5 is a solution, negative 1 is a solution. All those numbers that are greater than negative 2 are solutions to this linear inequality. So the solution set here is not just a number, it's a collection of infinitely many numbers. In order to be able to express the solution of a linear inequality, you need to be familiar with the interval notation. So if x is between a and b and can also be equal to a and b, then this can be represented as an interval like this. So I'm using square braces to indicate that a can be equal a, x can be equal a, and x can be equal b. If x is between a and b and it cannot be equal a, just greater than a and less than or equal to b, then the equivalent notation as an interval would be from a to b. I'm using a round brace on the a side and a square brace on the b side to indicate that x cannot be equal a, but x can be equal b. If x is between a and b and it cannot be equal b, I'm using this interval. So from a to b, square brace for a, round brace for b. If x is between a and b and it cannot be equal a and b, I'm using round braces for both of them. If x is less than a, then the equivalent interval is from negative infinity to a, round brace. X less than or equal to a, from negative infinity to a, square brace, indicating that x can be equal a. X is greater than a, so it's from round brace a to positive infinity, and x greater than or equal to a is the same as this interval, from a, square brace, to infinity. So here the square brace indicates that x can also be a. Okay, the way you solve a linear equation is very similar. The way you solve a linear inequality is very similar to the way you solve a linear equation. That is, you isolate x. The only difference is when you are multiplying or dividing by a negative number. So that's the only difference between linear equalities and linear inequalities. If you're multiplying both sides by a negative number or dividing both sides by a negative number, you have to change the direction of the inequality. So for example, I have 5x plus 2 greater than 22. I want to solve this. So I try to isolate x. I move 2 to the other side. I get 5x is greater than 22 minus 2, which is 20. I have to divide both sides by 5. I get x is greater than 4. In interval notation, that's from 4 to infinity. So that's my final answer. Notice that here I did not divide by a negative number. 5 is a positive number, so I didn't have to change the direction of the inequality. But consider this one: 2x minus 3 less than or equal to 6 times x plus 1. Okay, first I distribute the 2 here. I get 2x minus 6 less than or equal to 6x plus 6. Then I'm moving all the x's to one side, to the left, and all the numbers to the right. I get 2x minus 6x less than or equal to 6 plus 6. So this means that minus 4x is less than or equal to 12. Okay, at this point I have to divide both sides by sides by negative 4. So I divide by negative 4, divide by negative 4. And since negative 4 is a negative number, I have to change the direction of the inequality. So here, negative 4x over negative 4 becomes x, and 12 over negative 4 becomes negative 3. And since negative 4 is a negative number, I change the direction of the inequality. It used to be a less than or equal to, becomes a greater than or equal to. So the final solution is from negative 3 to infinity, including negative 3. So I'm using a square brace. Another example: 5x plus 7 is less than 2x plus 1. I move 2 to the left, the number 7 to the right. I get 5x minus 2x is less than 1 minus 7. So 3x is less than minus 6. I divide both sides by 3. 3 is a positive number. I don't need to change the direction of the inequality, so x is less than negative 2. In interval notation, that's from negative infinity to negative 2. Another example: 3 times 2 minus x is greater than x plus 5. I distribute the 3, I get 6 minus 3x is greater than x plus 5. Moving x to the left, I get minus 3x minus x is greater than 5 minus 6. So this gives me minus 4x is greater than minus 1. I divide both sides by minus 4. And since minus 4 is a negative number, I have to change the direction. This gives me x less than. It used to be a greater than, becomes a less than 1 over 4. Interval notation, that's from negative infinity to 1 over 4. You may also have inequalities like this. 3x minus 7 is between -4 and 3. Can be equal 3, but it cannot be equal -4. How do you solve these inequalities? So the first thing I need to isolate x. So the first thing I do, I need to get rid of these -7 here. So I add 7 to every side. I get 3x minus 7 plus 7 less than or equal to 3 plus 7 greater than -4 plus 7. That gives me 3x is greater than 3 and less than or equal to 10. Next I need to divide by 3. So I divide this by 3, I divide this by 3, I divide this by 3. I get x isolated between, and it is between 1 and less than or equal to 10 over 3. In interval notation, that's round brace 1 to 10 over 3 square brace. Notice that here I divided by 3, which is a positive number. I didn't have to change the direction. 3 minus 5 over 2 x is between 8 and 15 and 18. Okay, first let's get rid of this 3 here. I can do that by subtracting 3 from every side. I get 3 minus 5 over 2x minus 3 is less than 18 minus 3 greater than or equal to 8 minus 3. That gives me -5 over 2x is between 15 and 5. Okay, at this point I have to multiply everything by -2 over 5. If I multiply everything by -2 over 5, I have isolated x. Why is that? Because -2 over 5 times -5 over 2x, and here 15 multiplied by -2 over 5, and 5 multiplied by -2 over 5. So notice that I multiplied this by -2 over 5, I multiplied this one by -2 over 5, and I multiplied this one by -2 over 5. The reason is that now -2 over 5 times -5 over 2 is just 1, and x is isolated. Yes? So this one gives me -6, and this one gives me -2. But don't forget that since -2 over 5 is a negative number, I have to change the direction of the inequalities as well. So this means that x is between -6 and -2. In interval notation, that is -6, -2. Round brace on the -6 side because there is no equality sign here. Square brace on the -2 side because there is equality here. And notice that I first begin with -6 on the left and -2 on the right, because in the set notation, in the interval notation, you always put the smaller number to the left and the larger number to the right. So if you give me something like this, this is not good, this is not right, because -6 is less than -2. Okay, just show you some other examples of how you have to deal with these kind of inequalities. For example, if you have 1 minus 2x is between 5 and 10. First you get rid of the 1 here, you get minus 2x is less than or equal to 10 minus 1, 9, 5 minus 1, 4. Then you have to divide both sides by negative 2. Here you get x, here you get 9 over negative 2, here you get 4 over negative 2. You also have to change the direction because negative 2 is a negative number. So x is between negative 9 over 2 and negative 2. Again, notice that negative 9 over 2 is smaller than negative 2. So in interval notation, that's from negative 9 over 2 to negative 2, and using a square braces to indicate that it can be equal, both numbers. Okay, and that's it for solving linear inequalities.